In the previous episode, the students estimated how long it would take the amount of mold on their pizza to increase by a factor of 10 using a number line. In this episode, Josh and Arabindo try to more accurately determine the amount of time it takes for the mold to increase by a factor of 10.
So how would you like to try and figure out how long it takes to increase by a factor of 10?
So, I guess we're going to make like this expression where we do 3 to the x is equal to 10, I guess. Yeah.
Mm-hmm. And will that give you this time, or this time, or both?
Both.
Arabindo claimed that the x in the equation 3 to the x equals 10 will give the amount of time it takes the mold to increase by a factor of 10. The students claimed this x would give this time regardless of when the increase occurred. For example, the x represents the amount of time it takes for the amount of mold to go from 1 gram to 10 grams, and it also represents the amount of time it takes for the amount of mold to go from 3 grams to 30. They will now use a guess and check method to figure out what this value for x is.
And so how are we going to figure out what that x is?
Well, we know that x is more than 2. And it is less than 3, we know. It's in between 2 and 3.
Okay, so how are you going to figure out what it is?
Well, you can use a calculator and test it.
Okay.
So I don't know why I thought it was that, so I have no idea. 15.58, and we're trying to get 10, so that's too much.
The students were using a guess and check method and trying different exponents. They are looking for an exponent for 3 that will give them 10. They use a calculator to check their guesses.
So it's in between these two, so it's 3 to the, I guess, let's do 2 to 1 maybe. Okay, yeah, that should be close enough.
Okay.
Okay, so I was pretty close. I was just 0.05 off.
Mm-hmm. And can you write the little equation that you found with your calculator?
Oh, yeah.
The students used a calculator to find a more precise estimate of how long it will be for the amount of mold to increase by a factor of 10. They tried different exponents and found that 3 to the 2.1 was about 10. They claim this shows that it takes about 2.1 hours for the mold to increase by a factor of 10. Now they explain why by interpreting their equation.
Okay, and then can you tell me what each of the things mean, each of the numbers mean in that equation?
Yeah. So this is the growth factor per hour. And this is green. Why? I was about to say greens again. D.
Hour.
Yes.
So grams of mold at hour x, but there's no x in your equation.
Oh, yeah.
Okay. So where's the answer to my question?
This is the answer.
And why is that the answer?
Because we were trying to find the number of hours.
And we were trying to find the number of hours that it takes to increase by a factor of 10. But you've said that at hour 2.1, there's 10 grams of mold. So why does that give you the answer?
Well, you have this 10, and if you divide it by what you're starting with, this is 1.
Mhm.
means you have 10, so its growth factor was 10 over that 2.1 hour period.
Mhm.
And it has a constant growth factor of 10 over another 2.1 hour period. So from 1 to about 3.1, you have a growth factor of about times 10.
Do you agree with that, Josh?
Yeah.
That from 1 to 3.1?
The students have explained that from hour 0 to hour 10 and from hour 1 to hour 3.1, the grams of mold have increased by a factor of 10 as shown on their number line.
How do you know that from 1 to 1 to 3.1, it's going to increase by a factor of 10?
Well, you could check it if you want.
Okay, how would you check it?
Well, you would do 3 to the
3 to the
3.1
Mm-hmm.
divided by 3. Then the reason is that 3 to the 3.1 is the number that would be right here.
Mm-hmm.
And the 3 is the number that is right here. So that would give you the growth factor of it. And if it is about 10, then you know that you're right.
Okay, so can you use the calculator to check that? Mm-hmm.
No, what?
Wait, you can just
Yeah, just do that and then divide by 3.
what?
No, just
Can I just do that?
Yep, it's about 10.
And why do you think that worked out?
Because it has a constant growth factor over the same number of hours.
The students confirmed what they expected, that the amount of mold increased by a factor of about 10 over a 2.1 hour period from hour 1 to hour 3.1. Their calculator showed that the amount of mold at hour 3.1, which measured about 30 grams, divided by the amount of mold at hour 1, 3 grams, was 10.
Is there a way you could use logs to solve this problem to figure out how long it takes to increase by a factor of 10?
Yeah.
So what do you think that this is telling you?
So this is the logarithm symbol.
Yeah, it's just log, so you just call it log because it's spelled log.
Okay.
No questions.
This is the 10, which is the base. So the base to this exponent gets you this
Mm-hmm.
thing on the top.
Okay. So how could we use this calculator to figure out how long it will take our mold to increase by a factor of 10?
Well, we know that our base is 3. That's our constant growth factor.
Okay.
Oh, you can type.
Oh, yeah, so.
Oh, you can type.
Whoa, but that we don't want it to equal 100. We want it to equal 10. Oh, you could have just erased 1 0.
Okay. So what is this telling you?
It's telling you that 3 to the whatever number this is equals the thing on the top, which is 10.
Mm-hmm. So what does that tell you about your situation?
That tells us that it takes 2.09, about 2.1 hours.
So what is it telling you?
So it's telling us that it'll take about 2.1 hours for the grams of mold with the constant growth factor of 3 per hour to get 10 grams of mold.
How do you know that this 2.095, etc., how do you know that that's telling you the time it takes?
Well, we got a rule, and if you rewrite this would be 3 to the
3 to the whatever this is, 2 equals the thing on the top, which is 10.
Yeah, which is what our equation was, 3 to the x.
Uh-huh.
And this would be the x. So this is our answer.
In this episode, the students found the amount of time it would take the mold on a pizza to increase by a factor of 10. They determined that this amount of time would be the exponent you raise 3 to get 10. Originally, they found this number using a guess and check method. However, they then realized that because they were looking for an exponent, they could use logarithms. In particular, log base 3 of 10 would give this amount of time because this is the exponent to which 3 needs to be raised to get 10. In the next episode, the students will explore how long it takes for the amount of mold to increase by other growth factors.